Shall resume.
Thank you, Mr. Commissioner. Wendy Baker for the Commission. With me is Maya Sarumi. Today, tomorrow, and Wednesday, we'll be dealing with the topic of freshwater urbanization, and we've broken this up into three different groups of witnesses. The first group today is Robbie McDonald, gotta get his pronunciation right, and Andre Talbot. Dr. McDonald is from Fisheries and Oceans, and Dr. Talbot is from Environment Canada. Tomorrow we will have Sylvain Paradis, Lisa Walls, and John Carey. Again, Dr. Paradis is from Fisheries and Oceans, and the other two witnesses are from Environment Canada. And with those witnesses, we'll be talking about non-point source contaminants in the freshwater environment and toxics research, etc. The last panel will involve two people from Fisheries and Oceans, Michael Crow and Carino Salami from Habitat Management, and Stacey Wilkerson from the province, and we'll be dealing with physical impacts in the freshwater environment and primarily focusing on riparian impacts. So today I'm hoping to finish with this panel before the end of the day and start the second panel before the end of the day is my plan, because we have a lot to cover in these 3 days. Before we start, I do need to mark the PPR for this topic. It was circulated to all parties on May 11, 2011. It's called Policy and Practice Report Overview of Freshwater Urbanization Impacts and Management.
We've marked as PPR number 14.
Thank you. We'll begin then with the swearing in of the two witnesses, please.
Morning, gentlemen. You solemnly affirm that the evidence to be given by you through this hearing shall be the truth, the whole truth, and nothing but the truth?
I do.
I do.
State your name, please.
Andre Talbot.
Robbie McDonald.
Thank you. Counsel?
Thank you. I'll start with you, Dr. Talbot. Dr. Talbot's biography is document number 19 on our list, if that could be pulled up. And you are right now the Director of Aquatic Ecosystem Protectorate Division, Research Division in the Water Science and Technology Division of Environment Canada, is that right?
That's correct.
Okay. And this is your biography that's on the screen in front of you?
That's correct.
Microphone, please.
Apologize, that's correct.
All right, an affirmative answer to both questions. Could I have the biography marked as the next exhibit, please?
Exhibit 973.
Okay. And I'll just identify that you have a PhD in biology and population dynamics with an emphasis on modeling and statistical methods.
Yes.
And you've been with Environment Canada since 2004?
That's right.
Beginning as a section head for fluvial ecosystem research and moving then to your current position in 2008?
That's correct.
And your work over the years has included conservation biology, ecotoxicology, biostatistics, population dynamics, and quantitative population genetics.
That's right, along with a number of other things.
Okay, thank you. And Dr. McDonald, Dr. McDonald's biography is under number 2 of our list of documents. Dr. McDonald, you're presently the section head of the Marine Environmental Quality Section at Fishery and Oceans Institute of Ocean Sciences in BC.
That is correct.
Okay, and this is your biography you see on the screen in front of you?
Yes.
Have that marked, please.
Exhibit 974.
Thank you. And you have done extensive research over the 35 years, which is all set out in your biography, but your focus has been on, as you identify, 3 major subjects: the cycling of organic carbon in the ocean, cycling of fresh water in the Arctic Ocean, and contaminant pathways in temperate and polar aquatic systems.
That's correct.
Thank you. And how long have you been the section head of the Marine Environmental Quality Section?
I think it's approximately 8 or 9 years. I was an acting head for a fair period of that time.
During the 8 to 9 years you were in acting, or before that you're acting?
I was during that, during the past 2 years, I think I actually formally was sworn in.
Okay. So I want to just ask a little bit about your research focus on the fates and transport of contaminants. Can you explain what that is?
Well, as the CV says, I specialize in pathways, and when we release contaminants to the environment, they enter naturally cycling systems. Some of them are volatile, some of them tend to stick on particles, some of them like to go to organic systems. And so to understand the pathway part of this and the transport, you have to understand how the various systems move these around. The two great cycling fluids, water, the oceans basically, and the hydrological cycle, and the atmosphere get into that, and they will move contaminants long distances. And then within local sites, they'll start to move through particular pathways, including food webs, which is really what puts them at risk to ecosystems.
Right, so this work that you do, it looks at large-scale transport processes that can concentrate contaminants and maybe put ecosystems at risk, is that right?
It looks at large scale, but also small scale. There are many ways that contaminants get concentrated, and I'm interested in all of those.
Can you tell us what physical phenomena like biomagnification or migration, what are those concepts, and how do they relate, or are they relevant to Pacific salmon?
They are very relevant to Pacific salmon. For many of the contaminants we put out into the circulating systems, like PCBs, their concentrations are very low in water and atmosphere. So it requires some kind of process to concentrate them to make them a risk, and animals themselves can be part of this process. And for example, the concentration of a PCB in the water compared to what it might be in a top predator can be a factor of 1 million or more higher, right, in the predator. So what happens is when animals feed in trophic systems, they are basically transferring fat from lower levels to higher levels. And with the fat, they tend to transfer fat-soluble contaminants like PCBs and PBDEs. So they get concentrated as you go up the food web. They get concentrated initially because they like to transfer out of the water into the bottom end of the food web, like phytoplankton. And then when zooplankton eat the phytoplankton, they metabolize some of the fat, but they maintain the organo fat-soluble contaminants. And this goes on up into the zooplankton, into fish, and then into those things that eat fish. And salmon sit at about trophic level 3 in the middle, so they're not the worst exposed, but they're certainly accumulating these contaminants as they feed in the ocean to levels that are easily detectable. Now, the other part you're talking about in transport, salmon have this particular property of congregating in the same place. So what happens is these salmon all go out to sea and feed and accumulate their body mass, and they accumulate contaminants, and then they come back to a particular lake or natal stream. And so there might be 1 million fish that come into a particular lake, and there could be 40,000 of these per hectare. They spawn, they die. So the contaminants they bring back that way can sometimes exceed the contaminants that deposit in the system to start with from the atmosphere.
Thank you. We understand that there was a toxic chemicals program or mandate in the early part of the 2000s and prior within DFO. Was that changed in 2004, 2005?
Yes, we went through a couple of program reviews. 2005 and 2006 was a program review. And at that time, the toxics program that we had was clearly headed for a change. And we were tasked at a meeting in Ottawa to prepare for white papers on what the new toxic chemicals program would or could look like. And 4 papers were produced in the end of the day, I believe. And these would suggest a new focus on toxicity to fish, but really lose the pathway work. We had an ESSRF fund at that time, or before that time, that was proposal money that annually we put proposals in, and we did reviews of work we had in progress, and those funds disappeared at that time.
Strategic Research Fund?
That's correct.
And that fund did research within DFO on the types of things that you're talking about?
That's correct. It was distributed across DFO, and it basically supported the toxic chemicals perspective, and we would all put proposals in, and in Ottawa there was a vetting process that tried to make sure the funds were distributed on high priority proposals and with some equality across regions.
And so was contaminant work relevant to the Fraser system funded through that fund?
Yes, there was some work that was funded through that. In fact, I think the salmon transport work I mentioned, we got funds to do part of that.
And when that fund was eliminated, in what year is that, 2005?
I believe it was 2005, yes.
What funding came in to replace that?
Within DFO, none really. We depended on other external funds. There were pesticide funds that came in a different pot, and myself, I depended on things like Northern Contaminants Program, which was Arctic funds.
Okay. As part of the changes to the toxic chemicals program, were labs of expertise created within DFO?
They were created in a sense. We already had the labs really, but the perspective was to develop these labs into particular labs that would be used across Canada. So prior to that, we had regional labs and we did our regional work, and the notion here was to render it down to having labs that would cover all of the toxic chemicals that we had an interest in and have these distributed in different places for the sake of efficiency. So one was held at the Institute of Ocean Sciences, and that was an organic lab.
That's your lab?
That's our lab. Another one was held at Quebec. It was a combination of an organic lab, but they had lower resolution in the organo context, and they also did the metals work. In addition to that, we had a pesticide lab at Winnipeg, and we had what was called Cougar, which was a hydrocarbon lab at BIO. And we also had a radionuclide lab at BIO. Those were long-standing labs that were, I don't believe they were part of LICA.
What's BIO?
Bedford Institute of Oceanography. So in fact, within Department of Fisheries and Oceans, we had lab expertise to do pretty well all the contaminants.
And how did that changing of the labs fit in with the new mandate for toxic research? It
gave us certainly a lab facility to do the analyses. And we got high quality analyses in that way. And that was clearly available. And certainly if we could attract funding to do toxic chemical research on toxicity to fish with a broad definition of fish, then we could use these labs to send our samples to. And there was some savings in the cost in those labs because we were charged only operating expenses to do analyses, which made them fairly cheaper inside DFO than it would have been to go to a contract lab.
All right, so in your view, has access to lab facilities improved for DFO given this change in the structure?
I would say yes. I think that the lab system did improve. Certainly, the access to it across Canada was better, and it was much more transparent. So I think it was an improvement.
Okay. So before we were talking about the labs, we were talking about funding, and you identified that there was no new fund created to replace ESSRF. So where do contaminant researchers within DFO get their funds now? Well,
they get them by putting proposals into other programs that come along. IPY would be an example, although IPY really didn't do
What does that stand for?
The International Polar Year. They put a lot of money in, starting in 2007, to do Arctic and Antarctic work. Contaminants were not a big part of that, but that would be one source. There was a pesticide fund, so that was also a possibility. You could do collaborative work with industry, so we get some funds in that way as well. And so basically, it was looking for places you could put a proposal in or partner with other other organizations or through universities. There have been networks created in Canada to do research. These are cutting-edge networks. One of them is ArcticNet, and again, you can do work through that. So basically, it was finding funds outside of DFO.
Okay, and so does it mean that the DFO contaminant researchers are now essentially supporting other research priorities within the department at large or within other departments in government?
That's certainly a risk. I think most of the scientists try to find a win-win position, but for sure, when you do get money from another pot somewhere, it usually has some mandated mission, and that might not align exactly with DFO's mission.
Okay. So have there been changes then in how, what research is done in the Fraser system since the changes were made to the toxics program in 2005?
Yes, I would say so. As I mentioned earlier, the pathways work has been dropped officially from the system, so you can't really do that within DFO. Toxic chemical work you can do, but you have to find the funds somehow. And there have been various places that have come and gone to do that.
The work that, or the phenomena that you were describing earlier, which is the transport of salmon back to their natal lakes and the contaminant accumulation that results, is that part of pathways research that's you would no longer have any funding to do research on that aspect?
Strictly speaking, by itself, yes, it's a pathways piece of research. We did not connect that to the toxicity to the fish.
Source contaminants research. How do you do that?
You mean specifically like long-range transport?
Anything like that, yeah.
Again, most of the work that I've been involved with has been Arctic work, because we've had a Northern Contaminants program that has been mandated to look at contaminants in the polar ecosystem and health effects on humans. So they have been initially very interested in pathways and latterly more interested in human health. That in the Arctic, local contaminants and point sources are much less an issue, so they really are focused on long-range transport. So that's where we've gotten a lot of our funding. Those ecosystems are really set up no differently than ecosystems in the Strait of Georgia, so that what we've learned up there doesn't hurt us in understanding the Strait of Georgia, except that you might anticipate that being close to industrial and temperate agricultural sources, the Strait of Georgia is probably even more impacted by these kind of contaminants.
And that non-point source research in the Lower Fraser area is not being worked on right now by DFO?
Not really, no.
If I can ask you to turn to a couple of emails that are in the materials. Start with tab 4. This should come up on your screen in a minute, but it's in the binder at tab 4 if you want to follow it there. So this is an email from Robin Brown. Now, who's Robin Brown?
Robin Brown is presently my boss, and he's the division chief for Ocean Sciences, the Ocean Sciences division in the Institute of Ocean Sciences.
Okay, and he's writing this email to Laura Richards and others, and you're copied with this email, so you've seen it before?
Yes.
Okay. And the reline is effects of pesticide spraying on Pacific salmon, and if you look at paragraphs 1 and 2, this identifies, well, if we look at paragraph 2, this is an area of complex jurisdiction. Health Canada, PMRA, that's the Pesticide Management Agency, is that right?
That's correct.
Regulates the use of pesticides. Environment Canada focuses on point source deposition of deleterious substances under the Fisheries Act. DFO worries about more subtle ecosystem impacts of primarily non-point sources like surface runoff and complex mixtures of contaminants that are poorly addressed with Environment Canada's primary emphasis on point sources. This is exactly the kind of problem that's likely to slip through the research and regulatory cracks. And is it fair to say then that this pesticide spraying, the effects of pesticide spraying on Pacific salmon, is that kind of non-point source contaminant impact that's not presently being researched by DFO?
We have some research on it because Peter Ross is working on this issue from a fish toxicity perspective, but we certainly don't have a large program on it.
I'd like that to mark, please, as the next exhibit.
Exhibit 975.
And then the next tab 5 is an email, again, from Robin Brown to Kate Ladle. And I think you're aware of this email, you've seen it before?
I think I've been shown this in our discussions, but it was not copied to me.
All right, it says, the first paragraph that Robin Brown, the first full paragraph says, this is an area of tension. Oh, sorry, the reline is impacts of copper on salmon. And it says this is an area of tension between Environment Canada and DFO. DFO is largely withdrawn from the contaminants research field, at least on paper. There are still internally subversive elements at work, and I leave it to your imagination to decide where those elements might be located. The first part of that sentence, that there's a tension between DFO and Environment Canada, and that DFO has withdrawn from contaminants research in this area. Is that consistent with your understanding?
Yes, I would agree that the tension was that DFO had withdrawn from certain components of looking at contaminants, pathways being one of them, with the notion that Environment Canada was going to pick these up. But I think Environment Canada was not on the same page there, because they were not necessarily given resources to pick things up, and some things they were doing, but some things they weren't doing, and I don't think they picked those up. So there was an interdepartmental disagreement, I think, on what was being given over and what was being taken over.
Right, and then the third full paragraph, the very last line says there's pretty large gaps between what Environment Canada is prepared to do and what DFO is prepared to do, and this gap is largest in the marine environment. And you agree with that?
I would agree with that, yes.
Could I have this marked, please, as the next exhibit?
976.
Is there a coordinated approach within DFO as to what contaminants work will be done across the country?
Not really, not since we stopped our ESSRF proposal meetings in Ottawa annually and having proposal reviews. I think DFO has drifted apart since that time. We have a notion of what we do in region, and if scientists work together, as we did on a polybrominated diphenyl ether paper that we wrote, other than that, we tend to work at our own selected regions of interest and not so much with the others.
So could you explain again how the ESSRF fund worked to coordinate research interests across the country?
Well, there was a requirement, there's a funding pot that you could put proposals in annually, and you would do this with certain rules. There was some gatekeeping on it that said what kind of proposals would be looked at, and the division of kind of emphasis on targeted items, for example, toxicity versus pathways. And these proposals would be collected together, and we'd have a meeting in Ottawa to go over them and vet these proposals, to rank them, and come up with some view on how the next year's money would be split between regions and what they'd work on. We'd also have, from time to time, meetings in Ottawa that were program reviews, where we would get up and we would present our findings. So with those two kinds of processes, we had a communication that was Canada-wide and within DFO, so we had a pretty good notion about what other people were doing and proposing. And indeed, there was some encouragement, I think, where appropriate, for regions to work with one another on a problem. For example, the St. Lawrence is part maritime, part Quebec, and so there's an interest for both parties to collaborate.
And that, as I think you've just described, that process is no longer available to you with the dissolution of the ESSRF?
That's correct.
Okay. Isn't any environmental monitoring being done as part of the contaminants research that is still being done by DFO?
It depends on how you define monitoring. In my definition, the answer is no. We make measurements on things as part of proposal work. Sometimes you have funding for 1 to 3 years, and you might collect a set of time series data by doing this, but it can't be called organized monitoring.
Okay. Was baseline monitoring done by DFO in the past in the Pacific region?
For toxic chemicals, not really. There were ad hoc things done for some chemicals, and one can hindcast time series by using archived samples. But I don't recall any deliberate strategy to collect time series data for contaminants in fish, for example, or seals.
Is it your view that monitoring is important, monitoring for contaminants in the Fraser River system is important from a science or research perspective?
Yes, absolutely. monitoring has from time to time had a bad connotation in science. Some people think it's not science and don't like it. But I think monitoring is one of the ways that you can actually see what's happening in the environment. And you have to be frugal with your funds, and so you target things. But I think it's crucial to maintain a watch on your resources, and monitoring is one way you do that. They've recognized this as a central element in the Arctic, and the Arctic Monitoring and Assessment Program and the Canadian Northern Contaminants Program have both had long-term vested interest in monitoring. That monitoring is connected to the research that's done, and those two together help very much to assess what trends are, why things happen, when they happened, and who does it.
Does it also help to evaluate the success of a regulatory regime?
Yes, very clearly it's a way of looking at what the performance is. Sometimes surprises come out of that, because if your regulation is not appropriate to the contaminant source, nothing happens, or there are other components in the environment that cause things to go awry. So you have to have a fair amount of environmental understanding to understand exactly what means your monitoring results. But having said all that, very often, monitoring is really the key tool to tell you whether your regulation has had some effect that you wanted to make.
And you had mentioned earlier sediment sampling, and can you explain how that works and what its usefulness is?
Well, you talk to the heart of one of the things I like to do. If you don't have monitoring in place, and often we don't, because sometimes we wouldn't be aware of what to monitor for, and sometimes early in our chemistry we might not have tools adequate to monitor. In other words, we didn't have detection limits or sensitivity. But there are archives out in the environment that naturally assemble records. Sediments are one of those archives. So if you think about how sediments accumulate, each year a certain amount of new sediment is dropped on top of old sediment, and many contaminants are very sticky. They like to go to particles. PCBs are one such. PBDEs, the flame retardants, are also like that. And so what happens is these sediments, while they're accumulating, are accumulating a record of their exposure to contaminants. So if you collect a sediment core and you date it with radiometric dating tools, and then you analyze the sediments for a suite of contaminants, you can very often hindcast what's been going on in the contaminant exposure. We did exactly that with the dioxin and furan business that we had in the early 90s. We had this sudden emergent chemical. Nobody knew what had been happening with it. We collected several sediment cores, dated them out, and then we could say very clearly these things started coming in when chlorination of pulp mills started, and we could see the rise of them. We could even see the effect of the first year in the decline. We saw the whole story with those. So sediments provide a monitoring tool.
And is that sediment sampling that you've just described something that there's expertise for within DFO in the Pacific region?
Yes, there's expertise for that in all DFO regions.
Okay, and is there a difference in how that's done in a marine environment versus a freshwater environment?
There can be very much. Freshwater environments, people generally target lakes and lake sediments. Lakes are oligotrophic. They tend to be not very productive, so they don't have a very large carbon cycle compared to the marine systems. What that means is that the sediments accumulating in lakes often don't get mixed. They accumulate very nicely and they form very stable records, so you can set years of sediments against the contaminants, and so you get a very clear record. And in some lakes you get varve sediments. That is, there's actual annual layers, and you can go down to annual. In the marine systems, frequently there's enough organic carbon and benthic activity that the sediments get mixed in the surface. So that kind of smears your record. You can recapture that record by modeling it. But the tools to model it and the understanding of marine cores is quite different than freshwater cores, just for that context alone. The other context is that there's a lot of salt in marine systems, and you have to worry about that in the analytical part of it, but I think we understand that one pretty well.
Do you know what environmental water quality monitoring is currently being done by Environment Canada in the Fraser?
I was shown they have a report there, and I was shown a particular document that paged out what they were monitoring. Yes.
Okay, I'm going to take you to that. That's tab 8 contaminants are being monitored in the Fraser system. So that's an email. It was actually produced by Environment Canada as an assembly of information for the Cone Commission. And you'll see at the bottom, it says core monitoring parameters, and that actually goes over to the next page as well. Right. Is that what you're referring to, or you're remembering?
This one partly, and also there was a table with a list of things that they measured in rivers going, in freshwater going across Canada, in fact,
Okay.
by province.
That is, is that in the freshwater quality indicator document,
I believe it was.
tab 24? And then if you turn to page 15 of that document, it sets out parameters used across the country. That's probably not going to be 15 on ringtail.
Okay.
Yeah, 2 pages further there.
Yes, that's the table there.
Okay. So if I can just go back to tab 8, which is the email that has a summary of what's relevant for the Fraser system. Reviewing this email, are any of these, all the parameters there, stop there. Yeah. Are those parameters useful for the work that your group would do in contaminants research relevant to Pacific salmon?
You might describe them as necessary but not sufficient. These are what you'd call the pulse and blood pressure of rivers, most of these. In other words, they tell you about the general functioning. There's a certain amount of nutrient work being done there, nitrogen and phosphorus, and that tells you whether you've got a eutrophication problem or, in other words, is this river behaving normally? It's got temperature in there, and these are things you'd like to know. But like blood pressure and pulse, these don't tell you really anything at all about the contaminants we're talking about, the biomagnifying accumulating contaminants, for example, PCBs. You would get no information on those exposures. You get no information on pesticide exposure. You wouldn't know anything here about mercury uptake, for example. So none of those kind of contaminants that really concern us, pharmaceuticals, etc.
Could I have that email marked, please, as the next exhibit?
You're referring to tab 8?
Yes, tab 8.
Yes, that's 977.
Thank you. Are you aware of any work being done by Environment Canada in BC and in the Fraser system on contaminants?
We have some collaborations with people in Environment Canada to do contaminant work, and they provided us with data. So I know they've made measurements on water PCB, for example, partly at our request that they do so. We've partnered these things up. I know they've had a large program. They've measured a lot of things like PAHs, polynuclear aromatic hydrocarbons. So there is some work being done in freshwater environment.
Are you aware of a buoy that's monitoring water quality in the Fraser estuary?
Yes.
And do you know what that is, what it's monitoring?
I don't remember the exact shopping list.
Is it something that your group has used in their work?
We might use it, again, as background information, the same as we'd use this, but it wouldn't really help us with the contaminant business. It's not a way that you can do PCBs or pesticides or other contaminants of interest.
Is there any agreements right now between Environment Canada and DFO on monitoring in the Fraser system that you're aware of?
None that I'm aware of.
I'm just going back to the toxics program and the refocusing of that program in 2005. Toxicology remained within DFO, toxicology of contaminants on fish, is that right?
That's correct.
Okay. And is that toxicology work sufficient to provide advice for regulators on contaminants?
No. You could provide some advice. For example, if you found certain contaminants passing toxic thresholds, you might red flag those and write a briefing note to your management and say, we've got a concern with PCBs. You would really be not able to say why you had that.
What about we've heard before in these hearings about L50 tests, lethality tests. Are those appropriate for migratory fish?
Well, it depends on the context of the question. The L50 tests, or these toxicity tests, are what I'm not a toxicologist, and I should be very clear about that, but I call them a belly upness kind of test. Does this kill the fish? The contaminants that we're talking about and the stresses on fish themselves in their life cycles isn't really about belly upness. I mean, I think we know very well when we have a spill of something and we kill a lot of fish. We've seen that, and that was certainly something we saw a lot more of in the 1950s and 60s, and we understand that pretty well. What we're talking about here is sublethal effects, things that affect endocrine development, that affect immune function, affect olfaction for fish, and these are very subtle. They fly under the death radar. You're not going to see them show up in an L50, and yet they may be every bit as risky for the fish in their life cycle as these things that kill them on the spot. What happens, and we have one case from New Brunswick, some research done by Wayne Fairchild that showed exposure to nonylphenol in the river didn't kill the fish outright. They went out to sea. They just did not come back.
And was that research that you're referring to, did that have a regulatory impact ultimately?
Yes, I think it did. I mean, it was a very nice piece of science work, and I think they learned a lot out of that. And of course, they realized that the nonylphenol, which was actually not the pesticide, it just carried the pesticide, was something that they would not want to be spraying in drainage basins at sensitive times in salmon habitat.
Does the toxicology work that is now being done by Fisheries and Oceans address the cumulative effect of contaminants or non-lethal, sublethal effects of contaminants?
What could you clarify what you mean by cumulative?
Does it address the effect of multiple contaminants being received by a fish, or contaminants being received over various stages of the life cycle of the fish?
No, it does not do that. These are very difficult topics, and are really the topics at the heart of whether or not these contaminants have an effect, but no, we don't.
Do toxic chemical and contaminant scientists or managers within Environment Canada sit down with their Fisheries and Oceans counterparts to discuss what work Environment Canada is going to be doing on contaminants and what work Fisheries and Oceans is going to be doing?
Not to my knowledge. The communication on work planning is more ad hoc, where either managers that have an issue in common or scientists that have an issue in common will come together and we'll discuss how to work on a specific issue, how to collaborate. But to my knowledge, there's no formal process to do that between DFO and EC.
And Dr. McDonald, do you have any different perspective on that?
My perspective would be more at the scientific level, and again, the word ad hoc would come up.
And Dr. McDonald, is there a coordinated approach with Environment Canada as to work being done that's relevant to fish health in the Pacific, just to bring it closer to home here? Not
that I'm aware of. We collaborate with them, as I said, on an ad hoc basis, and some work we've done together with scientists in Environment Canada based on programs. The Fraser River Action Plan was one such, but it's not an organized thing.
Now your section, Marine Environmental Quality section in BC, does provide some science advice on contaminants that affect Pacific salmon still, is that right?
That is correct.
If that work stopped being done by your section, is there another branch within Canada or department within Canada that would pick up that work?
None that I know of.
Dr. Talbot, is it work that you think would be picked up by Environment Canada?
Could you repeat the whole question just to be clear?
Sure. I was asking Dr. McDonald if his section, the Marine Environmental Quality section, stopped doing the science advice on contaminants work relevant to Pacific salmon that it's presently doing. If that work stopped being done by Department of Fisheries and Oceans here in BC, would it be picked up by your department, by anywhere in Canada?
Likely not. The work that we do tends to focus more on contaminants and their potential risks to the environment. We don't really focus on a species such as a salmon, particularly not if they're in the ocean. It's not strictly part of our mandate. So for us to pick up this kind of work, we would really have to go back up to a policy level discussion and determine if that becomes an issue for Environment Canada to get involved in. At this point, it's considered to be a DFO mandate issue within Environment Canada.
Thank you. Dr. McDonald, at tab 11 of the materials, there's an email from Peter Ross to Jocelyn Helou. Who's that? Jocelyn Helou.
Jocelyn Helou is a research scientist at the Bedford Institute of Oceanography. She works very much on toxicity and metabolic pathways of organic compounds. Polynuclear aromatic hydrocarbons is one such, but she also works with organochlorines.
Okay, if you move to the second page of the email, this is a correspondence between her and Peter Ross, and it's outlining some of the difficulties in understanding which department is doing what research. And if you see, almost at the bottom of the page that you see on your screen there, stop moving the screen. Let me count up again. 4 bullets up or so, there it says there has been no clarification between DFO and Environment Canada as to which agency is responsible for conducting contaminants effects work in aquatic marine environments, such that no agency presently admits responsibility for this activity. And that, I take it you would agree with that?
Yeah, I would agree with that view.
And Dr. Talbot, is that also something you would agree with?
I think there's a lot of subtlety here. It's difficult. Depends what they mean by this activity. I'm not familiar with the email. I would have to look at it fairly carefully. But we do have a prioritization process for our work, and that prioritization process might include some of the work, that would concern sockeye in the Fraser River in a broad sense, particularly with respect to contaminants of interest for the discussion, or conditions under which those contaminants are found in the environment and their sources.
What about in the marine environment?
The marine environment, we would, again, we do some work. It's of limited jurisdiction, or it's limited capacity right now, simply because of availability of funding to do that.
Okay. Can I have that mark, please? That's the next exhibit.
Exhibit 978.
And if I could ask you to turn to tab 13, it's another email with Jocelyn Helou. It's from you, Dr. McDonald, to her. And you'll see the embedded email, which is from her to Robin Brown, and you're copied on it. And she says here in the second paragraph, government research should also be preventative, discover potential problems before they arise. This is what the handful of toxic chemical researcher should be funded to do. I will let you decide if we should have an exchange about that. Roby was going to, but it seems to have changed his mind, it seems, and then you respond and you identify that you're still a strong supporter of a healthy contaminants program within DFO, both in terms of analytical skill and ability to focus on leading issues of importance to fish. Can you explain what that dialogue is referencing?
I think at this time, this is written in 2009 here, we'd had this toxic chemicals review, and we'd been tasked to produce white papers, and we'd produced those, and they'd gone up the system. The money had disappeared from DFO, and the contaminant people working in this system here felt abandoned. I mean, they did. And emails like this came to me to say, what's happening here? What are we supposed to do? And basically the mandate was it's toxic chemicals, and go find its toxic effects and find your own money. So there was a bit of a groundswell to say, it's not unlike the mice that were looking around for somebody to tie a bell on the cat. And what they felt was that somebody should go to a high level in Ottawa and raise this issue. In other words, Wendy Watson Wright, the ADM, or at that level, and say, we have a contaminant community. They've got a history of expertise. We've asked them to turn a corner, and they're floundering a bit because they need some direction. And maybe is money going to come back, as was not promised? But at least that was a conclusion that was possible. But there was a lack of communication downward on it to the various players, and so, as the person that would perhaps face this problem, I got selected for a number of reasons, one of which is I'm a senior, and another which I'm so senior that I'm retirable, so that if I got in trouble, it wouldn't matter. And I was perfectly happy to do that. But as I noted here, I think timing was important. And we were going through a new budget right at that time, and I said, this management's got a lot more on its plate than this, and we want to come out with a well-phrased, well-formulated question to them. I also didn't want to just give my opinion on it. I said I had communications with people when I was at meetings and that, and said this is a community thing, and I expect everybody would contribute to this conversation, and I would be willing to take our community view in a respectful conversation with management and see where we got with it.
And what ultimately happened?
Wendy took a job over in France, I think. Nothing happened on it.
Yeah.
Yeah, if I can just add very briefly to that, we have to be fairly careful with these kinds of emails. Scientists, when there are changes to priorities and as programs are maturing, sometimes their sources of funding or their directions will change. And there's always a natural reaction of pushing back and saying, well, my work is extremely important. And a lot of these emails occur when there's a transitions phase, as programs mature. And some of these are questions to management. While the prioritization, and I think I'll be talking about that maybe a little bit later on, prioritization is both a top-down and a bottom-up approach where management will determine what the priorities are for programs and direct its scientists to focus on those.
Thank you. So I have just a few more questions for Dr. McDonald, and then I'm going to be moving on to Dr. Talbot. Oh, sorry, yes, I should mark that as the next exhibit. Thank you. Dr. McDonald, is measurement of contaminants a useful thing in supporting ecosystem-based management?
I think it's certainly a necessary tool, yes.
Why?
Contaminants have been shown to cause ecosystem health problems. So if you're not measuring them, you're missing a piece of your ecosystem health.
Right. And in your view, does Environment Canada have the capacity to do contaminant fates and transport pathways work in relation to Pacific salmon?
They haven't had the interest, and I don't think they have exactly the expertise to do it. The expertise to do the marine side toxic chemical work really resided in DFO, in my view. So I think it was a DFO specialty.
And Dr. Talbot, what's your view on that? Does Environment Canada have the capacity to do contaminant fates and transport pathways work in relation to Pacific salmon?
Environment Canada does have a substantial capacity to do fate and transport research on contaminants. And we do, it's part of my central mandate of my division under Water Science and Technology. We would be particularly capable of doing that type of work on freshwater fishes. As the work concerns marine species, we don't have the exact expertise, and we would have to develop some expertise in this area where we would need to understand mode of action of contaminants in saltwater fishes, and that really hasn't been our mandate or our interest in the past.
And I guess I'll ask both of you as well, starting with you, Dr. McDonald. Does Environment Canada have the capacity to do toxicology work on Pacific salmon?
They have capacity to do toxicology work because they do it. They have labs in Burlington, and they've done such work. They have not been doing it with Pacific salmon, and I think given the expertise on genetics and other things on fish lives, on marine fish lives, which resides in DFO, if they did do it, they would be better served to do it in collaboration with DFO scientists.
Including the scientists in your department,
Yes,
such as Peter Ross?
such as Peter Ross.
And Dr. Talbot, do you have views on that? Does Environment Canada, or do you want to add to what Robbie McDonald just said?
Yeah, Environment Canada, and especially Water Science and Technology, does have the expertise and a substantial amount of expertise on toxicology work for many living organisms, all the way from salmonids to very primitive forms of life. Again, the work is the type of work that we would be doing on Pacific salmon would be somewhat outside of our mandate or interest at present, because of the responsibility for anadromous fish rely on DFO, and this is the way Environment Canada has interpreted the mandate. We would be capable of doing toxicological work on many salmonids, particularly in freshwater phases. It would be more difficult for us in our given our expertise and our facilities to do work on saltwater phases or saltwater fishes.
And what about, we might have touched on this already, but maybe I'll just ask it to both of you. Does Environment Canada have the capacity to do research on non-point source contaminants in marine systems? Dr. Talbot, I'll ask you.
We make, in terms of our mandate, we do not distinguish between contaminants that are from point sources or non-point sources. We focus on the fate, transport, and presence and effects of contaminants of point and non-point sources in my division on aquatic ecosystems. And we also work on the toxicity of the substances that might originate from non-point sources. So we have the capacity and we have the mandate to do so. The question is more what's the context for the work in particular, because as we deal with non-point sources, the work on the sources of the contaminants, or how the contaminants are managed, is of a mixed jurisdiction at this point.
What about in the marine area? Do the answer that you just gave apply to marine systems as well?
It would also apply to the marine environment. We would do work, for example, on we could potentially do work on presence of contaminants in marine systems and the transport. For example, we do work on appearance of contaminants in the Arctic as they are transported through the atmosphere or the ocean currents. But that is very limited amount of work, and it's on the it's directed to the prioritization that we would have in our specific programs and our interest in those programs and to the level at which we would want to be involved. Some of that work is funded from external sources, such as the Arctic work is funded by Indian and
Northern Affairs?
yeah, thank you.
And how much of that kind of work is being done in the Pacific region by Environment Canada in the marine environment?
To my knowledge, there is no work of this nature.
You had mentioned earlier priority setting, and I'd like to ask you now, how is priority setting done for Environment Canada research programs, Dr. Talbot?
The prioritization of research is, it involves many steps. First is we obviously rise to the mandate where our mandates originate from, and a substantial component of our mandate comes from the Canadian Environmental Protection Act, Part 3 of the Act, which directs us to look at the effects of contaminants on ecosystems and how ecosystems alter the contaminants and their persistence, bioavailability, and effects on living organisms. And we also do work on through Part 5 of the CEPA, the Canadian Environmental Protection Act, which directs us to look at the toxicity of specific substances as identified by the risk assessment process, which is a confidential government program under the Chemical Management Plan, to provide the types of information that the risk assessments and regulators need to determine if a substance should be managed as a toxic substance in the environment. There's other acts as well, such as the Canada Water Act, which gives us broad responsibilities under the action plan for clean water, and other types of policies of that nature, specific ecosystem programs to work on specific hotspots ecosystems, such as Lake Winnipeg or Lake Simcoe or the Great Lakes St. Lawrence ecosystem, for example. And in those programs, we're to look at what are the factors that are causing ecosystems to be in decline and altered by contaminants or multiple sources of pressures, in fact, not just contaminants, but all stressors to the environment, and to develop an understanding of how those ecosystems are affected, and eventually provide information for compliance or regulatory activities.
And the ecosystems that you're referring to that are prioritized right now, do any of those include the Pacific region where we would have sockeye salmon moving through?
We don't have a Fraser River or Pacific Coast ecosystem program right now that allows us to prioritize work on Pacific salmon rivers and streams.
Thank you. And Robbie, Dr. McDonald, sorry, you had something you wanted to add?
That's fine. You suggested I would comment on the earlier question about transport.
Oh, I'm sorry. Yes, I moved along.
Would you like to repeat the question?
I think what I had asked was whether the Environment Canada has the capacity to do research on non-point source contaminants in the marine system.
Right. My viewpoint is a bit different. Environment Canada, in my association with them, has been a very strong partner in atmospheric transport, and that has been definitely a huge focus for them. Anytime I've wanted advice or written a review paper on transport systems, I've gotten Environment Canada scientists to help me with the atmosphere. In the marine system, they are much weaker. And basically, when it comes to reviews and whatever, it's the other way around. And I have been asked numerous times in assessments to provide the marine transport context. That's both in the Arctic and the Pacific. Virtually all of the marine transport knowledge we have that comes out of the Arctic Ocean is DFO on the NCP side of things. It's either work that I've done or John Smith at Bedford Institute.
Mr. Commissioner, we could take the morning break now. I've only got a few, maybe 15 minutes left of this panel.
Hearing will now recess for 15 minutes.
That's my view.
Yeah. It's more of a
Downstairs. I'm going downstairs.